The leading coefficient test helps you to determine the left hand and right hand behavior of an nth degree polynomial. Suppose you have a fifth degree polynomial, so let's say x to the fifth minus x to the fourth plus x to the third minus x squared plus x plus 5. So the graph, I don't know what the graph looks like, but you are going to get some curve, right? So for the leading coefficient test, you are going to look at the leading degree and the leading coefficient, and then using these two numbers, you can determine what the left hand behavior is, what the right hand behavior is. Let's take a look at the first graph. So for the first graph, we can see that the left hand falls, and then you can see that the graph falls to the left and rises to the right. So how do we determine this? Let's go over the leading coefficient test. The first line you see in here is an nth degree polynomial. Nth degree polynomial, we have n terms. F of x equals to an x to the n plus an minus 1 x to the n minus 1, and then you keep on going. You have the third degree, second degree, first degree, and a constant. So what we have to look at is the leading degree. What is the leading degree? The leading degree is the biggest exponent, which is n, and then the an is the leading coefficient. The entire term an x to the n is called the leading term. That is the leader of the entire polynomial because this term has x raised to the largest exponent. All right? Now, every time you determine the left hand and right hand behavior, you have to check the following. Let's read this sentence. The left hand and right hand behaviors, either rise or falls, are determined by the leading degree. You have to check out the leading degree and then ask yourself, is the degree odd or even? And the leading coefficient, is the leading coefficient positive or negative? There are 4 cases, so let's go over this one by one. The blue case is when the leading degree is odd, and then the leading coefficient an is positive. The graph falls to the left and rises to the right. So let's check out this graph, falls to the left and rises to the right. So what about this like dot 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 in the middle? So we do not know what is in the middle because the leading coefficient test helps you to determine the left and the right hand behavior only. We cannot determine what is in the middle. And then to make this short, I will just write OPFR. What is OPFR mean? O is odd, P is positive, F is 4, R is right. So you check out the leading degree first. Leading degree is odd, leading coefficient is positive, so falls to the left, rise to the right. And then the green curve, the second case, when the leading degree is odd, the leading coefficient is negative, the function rises to the left and falls to the right. So to make this short, I write ONRF. The leading degree is odd, the leading coefficient is negative, rises to the left and falls to the right. That is the second case. And then the third case, when the leading degree is even, do you follow this? I am right here. When the leading degree is even, the leading coefficient is positive, the function rises to the left and rises to the right. To make this short, EPRR. Leading degree is even, leading coefficient is positive, rises to the left, rises to the right. And then the last case is when the leading degree is even, the leading coefficient is negative, the function falls to the left and falls to the right. I use ENFF. Even leading degree, negative leading coefficient, falls to the left, falls to the right. So on the test, all you have to do is you memorize these 16 letters in this order. You have to memorize 4 cases. Case 1, OPFR. Case 2, ONRF, EPRR, ENFF. To me, this is way better than memorizing the entire sentence. Again, memorizing these 16 letters is way better than memorizing this long sentence. And then what about turning point? Turning point is a point on the graph where the slope changes from positive to negative, or from negative to positive. Positive slope means increasing, negative slope means decreasing. So let's say we have a curve that looks like that. This curve has 4 turning points. So the first turning point, let's just call that a TP. Increasing to decreasing, just like playing a roller coaster. Going up, going down, you have a turning point, going down, going up, turning point, going up, going down, another turning point, going down, going up, another turning point. Now, let's say you have an nth degree polynomial. How many turning points do you expect to see? So here is the answer. A nth degree polynomial has at most, again, check this out, at most, n minus 1 turning point. So let's say you have a third degree, y equals to x to the third plus 4x. Do we care about the first degree? Do we care about the second degree? Because the second degree is missing. I have third degree, first degree. There is no second degree. There is no constant. Do we care about those terms? The answer is no, we do not care about those terms. All we are looking at is the biggest degree, the largest exponent, which is 3. So this is a third degree polynomial. N is equals to 3. 3 is the highest degree. So this polynomial has at most n minus 1, which is equals to 2 turning points. What is at most mean? You will have to understand this in mathematics. At most means the maximum is 2. It can be 2, it can be 1, it can be 0. So in this case, we have 2. This is the graph. We have 2 turning points. At most means the maximum is equals to 2. It can be 1, it can be 0. Another good example is you have x to the third power. So the largest degree is 3. This is a third degree. This is a third degree as well. The green third degree has 2 turning points. The purple third degree has no turning points. But according to the logic, this third degree polynomial x to the third has at most n minus 1, which is equals to 2 turning points. But in fact, when you check out the graph, there is no turning point because x to the third power is increasing the entire time. So there is no turning points. But you might say, hey, you just calculate 2, but you say no. That makes sense because that's why we use the word at most, and that's why I put the at most in red. At most 2 means including 2, including 1, including 0. How about at most 5? At most 5 means including 5, 4, 3, 2, 1, 0. What about at most 4? At most 4 means 4, 3, 2, 1, 0. How about at most 10? At most 10 means 10, 9, 8, 6, all the way to 0. Alright, so that is the end of this lesson. If you like the way I explain leading coefficient test and turning point, give me a like, give my channel a subscribe, and I will meet you all in the next lesson. Signing out.